Imagine you could hop on a spaceboat, raise your central mizzen, and soar off into the stars on interstellar winds. Sounds pretty cool, right? Well, when we're talking solar sails, turns out that science fiction isn't too far from science fact. I'm Rae Holcomb, a second year physics student at Rice University. Come cruise with me. A solar sail is a form of spacecraft propulsion that uses the radiation of sunlight to move through space. The idea goes all the way back to Johannes Kepler, who noticed in 1604 that comets traveling through the night sky have a gas tail that always points away from the sun. What if, he proposed, the sun gave off some heavenly breezes that caused this to happen? 2.5 centuries later, in 1865, Jules Verne wrote about light-propelled spaceships in his science fiction novel From the Earth to the Moon. Since then, the concept of riding the solar winds has captured the popular imagination. So how do they actually work? Solar sails operate because photons, or particles of light, carry momentum and thus can exert forces on objects they hit. The sun puts out a lot of light, so even though the force from each individual photon is teensy tiny, with a big enough surface, you could theoretically propel a spaceship to other planets. This effect has actually been put to use by scientists for decades. Since the 1960s, engineers have learned to correct spaceflight trajectories since the typical craft headed to Mars can be displaced thousands of kilometers by solar radiation. Some probes have even used radiation pressure to their benefit. The Mariner 10 mission harnessed the sun's light to stabilize itself and take high-quality photos of Mercury and Venus. The Kepler mission was actually saved when scientists realized they could use solar wind to orient and stabilize the massive space telescope after two of its four reaction wheels broke. A disaster that should have left the $600 million mission drifting in space was saved by the pushing power of light. Then, in 2010, the Japan Aerospace Exploration Agency launched Icaros, which became humanity's first interplanetary solar sail spacecraft. Across 6 months, it accelerated on its 14 by 14-foot sail to a speed of 100 meters per second, or about 220 miles per hour. Not very fast for a spacecraft, but cut it some slack. It was the first one after all. Now ambitious plans are in the works for more of the sails. In 2016, the Planetary Society will launch Light Sail 2 to further explore the capabilities of solar sails. More distant missions are developing light-powered ships that could fly to nearby asteroids or even ride the beams of high-powered lasers to other star systems. The future is sailing towards us fast, and it sure looks bright.